Wait, isn't that recording? It's not recording. Good afternoon, everyone. My name is Muhammad Gadadhat, and today I will be presenting about mastering Kotlin coroutines for asynchronous programming in Android development. So, right. So I will just want to start my presentation with acknowledgement of country. I would like to acknowledge the traditional custodians of this land on which we meet on today, the Jigra, the Gaibal, and Jarawar people. I would also like to express my respect for elders present with us here today and extend my respect to all the generations present, past, and emerging. So I know I wasn't meant to do a background about myself, but I'm not gonna go through it. I just want to say that I am a fellow here studying a computer systems engineering. It's an honors degree, and one single interesting fact about me that I do promote or advocate for open systems like Android, and that's why I am presenting about the Android development today. All right, so I will start by introducing the topic. What is Kotlin? Kotlin is basically the main development. It's an programming language that is used to develop or apply or make applications for the Android operating system. It was announced in 2016 to the world, or brought to life to the world, by a company called JetBrains. And then Google decided to start supporting it in the Android Studio, Android TV, and so many other Android platforms. Also, Kotlin uses many interoperable and similar components with Java. So for developers, it gained much quick popularity because of the fact that it had that connectivity with Java, specifically in the back-end field. All right, so let's state the problem. What's the problem that we have here? The problem is that we had the previous programming styles that we had before involved using things like or operators or styles like using threads, using async task, and using that, the laser is not showing. Okay, and using RX Java. So the problem, I will start going through the problems with each one of these. So the first problem with the first problem with threads, that threads were basically a kind of a manual way to manage tasks. So the developers had to set the start and the end of each task and also synchronize each thread with the other. The problem with that this was a very resource intensive process, and it takes long time. So to do, while also doing the synchronization with each thread and the other, that makes lots of dilemma for the developers. The second issue with that we have with async task is that async task had an issue with its life cycle. Once you start basically a task using async task, or a process using async task, once you start it, it's very hard to end it, and it takes very long time to end it. That's one issue. The second issue, that it was depreciated in Android API level 30, so it's basically dropped. No developers use it after that version. The third one we have which is RX Java. The RX Java had the same problems as the other two, while adding the extra challenge of having the fact that developers need to learn reactive programming style or reactive programming concepts to be able to use the RX Java. And as I mentioned before, it was implemented in Kotlin and everything. But the thing is, if you want to use it, then you gotta learn how to do the reactive programming. For those who don't know what is reactive programming, it is the previous version of what I'm going to discuss today, which is asynchronous programming, which involves creating different parallel tasks running to each other. But that was the older version, so you can imagine how the technology have evolved. All right, so let's talk about synchronous and asynchronous programming. What is synchronous and what is asynchronous programming? Synchronous programming is basically you have a process starting. So suppose process A. Process A needs a response from process B. Process A gets paused, process B starts. Once process B returns an answer for process A, process B is paused, and then you have process A continuing from the point that process B got paused. With asynchronous programming, that gives the developers much more flexibility, because now we have process A running, it keeps running, even though it's waiting for the response, it keeps working in the background very normally. And then you have process B running for the time that needs to be run for until we extract the answer or the point that we need to extract it from process B and implement it in process A. So I will just add a few more points about that we had in synchronous programming. It's not very practical for users, not also recommended for large scale applications and deployment of data pipelines or any other huge models that you want to develop. Also with synchronous programming, you can only have, as I said previously, one process running at a time. So you cannot have more than one process running at a time. With asynchronous programming, that's when we introduce the fact that we can have more than one process running parallel to each other. And this gives the developers the capability to actually deploy multitasking, to have, and that's actually multitasking, not like the multitasking where you have to stop a task and then pause and juggle between tasks. No, the actual tasks are running in real time together. And also it is very useful for the deployment of AI models into Android apps. All right, so let's talk about Kotlin routines, and that's the solution for our problem statement that I mentioned previously. What are Kotlin routines? Kotlin routines are as a subsidized or a lighter version of what was called previously as threads. They give the developers the capability to start and end tasks based on their needed or their when you need to use the task or when you need to actually extract information or get a response out of a process and then end it or suspend it afterwards. Also, coroutines were introduced in Kotlin in version 1.3. Coroutines has to be used while using asynchronous programming. That's a very important part. All right. One more thing also should be noted that it gives you the flexibility, as I said, to juggle between different processes. All right. So what we have, I want to talk about three main operatables or building operators in the coroutines in Kotlin. The first operator we have here is the operator of lunch. What does it do? Lunch is a building operator that is used when you have a process that needs an answer or needs a response. But that response is not necessarily needed for the user to interact with it further, or you don't want to carry out any more operations with that response. And you can see here in this example, we have red blocking, the main coroutine, and then the sub coroutine lunch. It just will run independently of the main coroutine, and then the delay, the print happens, then the run blocking prints the hello. All right. So the next one we have is the opposite of it, which is async. What is async? Sorry, before I jump to async, I should also note that an example of using the launch command is when you want to send an update in the background or do some bug fixes that the user is not going to interact with, or change a color of a logo or something inside the app. With async, async is the second building operator we have today that I would like to discuss. And async, basically you use it when you are going to use the response from process B into process A. So you're not going to suspend process B. You're going to still reusing the response from process B. So you still want that to keep happening. And you can see the example I have mentioned here that like you want to ask the user for their location. So you can use that location coordinates to calculate, for example, the time for the sunset. A code snippet here shows you, again, the main coroutine, which is run blocking. And then we have a sub coroutine, which is the async. Okay. And then it simulates along computation or IO activity, which is basically the delay that we have here. And then it returns Kotlin coroutine, then the main run blocking function come back and returns those two printing statements. All right. So the last one I would want to talk about is the main one. So the previous two ones were a sub coroutine one, but this is a main coroutine one. Run blocking. Run blocking is usually used by developers in the beginning of the code or the app. You will never see it used in the middle. Why? Because as I mentioned previously, coroutines are a lighter version of threads, and this is the main thread. You want to make sure as a developer that the longest operation or the longest task possible, that's when you put it in the function or of run blocking. Also down the line, I will discuss the fact that run blocking acts as a parent function that encapsulates all the other building operators like launch and async and so many others. All right, so last thing I want to talk about in today's presentation is structured coroutines and concurrency and what's the benefit of that. So the thing with structured coroutines is that if you do not build structured coroutines and you have just random sub coroutines floating around, you will have basically memory loss and you will have processes that are orphaned. And that brings me back to the point where the run blocking comes. If you don't have a parent operator, then that controls or encapsulates the sub operators, then these operators will continue to keep running in the background, causing a high consumption of processing power and RAM, and of course battery life, because we're talking here on Android phones. And this is this is a code snippet here, just to show. This is an example by mistake made deliberately to show you that this sub coroutine will keep running indefinitely forever and ever and ever because there was no parent coroutine for it. All right, so in conclusion, what I want to get to here in today's presentation is that structured concurrency and structured coroutines are very important to use and to be able to know how to use them and when to use them. The reason why I'm presenting this today is to tell you the benefit about them, and the benefit about them where when we have an Android device, let's suppose your mobile phone, tablet, whatever, these devices have smaller batteries, smaller RAM, smaller everything. Although we are having advancements in hardware and CPU capabilities, we do still need to make sure that we use every single bit of these resources efficiently, not just using it because in a traditional way, how we had the previous programming style with previous threads, async task, and RX Java. All right. So thank you for listening to me. I know I have been talking very quickly, but before I open the open for the Q&A, I have three things I want to ask. The first question is, if you have been paying attention, when was Kotlin developed? Can someone answer? Nobody? Okay, I was talking to myself. I said 2016, but close one. The second question, can anyone highlight for me a single difference between synchronous and asynchronous programming styles?
You just let it run independently. It doesn't rely on each other.
That's correct. And the third,
run like PLCs. They're multiple.
I am not an electrical engineer. I'm a computer systems engineer. Can we please get in topic? Thank you. The third question that I would like to ask is, what is the sole purpose for using Kotlin? Like, what was Kotlin developed for, or what are we using it for? Big logo here.
Green robots.
No, it's not the answer. The answer is to be used for Android development. Now I would like to open the panel for the lecturers and the students. Does anyone have any questions to ask? Please fire away. Okay.